Question 2.1. Given the geometric sequence negative 1 over 4, b and negative 1, they want us to calculate the possible values of b. So we have this the geometric sequence, which is made of the following terms: negative 1 over 4, b, and negative 1. So now they want us to calculate the possible values of b. So b is a variable in this case. So since we know that these terms are in geometric progression, it means the common ratio is the same. So we have the first term, the second term, and the third term. So in other words, the common ratio is given by the ratio between two consecutive terms. So we always start with the term that comes after, divided by the term the previous term. So in that case, we have t2 over t1, and it's also equal to t3 divided by t2. So since these terms are in geometric progression, so that means the common ratio are the same. In other words, if we say t2 divided by t1, t2 divided by t1 is, we can write it as, because t2 in that case is b, so we have b divided by t1 is negative 1 over 4. So this is the common ratio, which is also equal to t3 divided by t2. t3 is negative 1, and t2 is b. So now at this stage we need to solve this equation. So to solve this equation, we are going to use the cross multiplication method, since we have the fractions. So here I'll just remind you that if we have a over b is equal to c over d, so that is also the same as when we cross multiply. So we are going to get a multiplied by d is equal to c multiplied by b. So the reason to do that is to modify my equation in such a way that it does not present the fraction, because this is an equation which is made of fraction. So the only way to do that is to cross multiply. So I'll first work out this. I'm gonna simplify this. So this is the same as negative 4 over b. So because I have I need to cross multiply, and then I'm gonna say it's equal to negative 1 over b. So how do they get negative? So how do they get negative 4 over b? So it's simple. If I have b over 1 divided by 1 over 4 is the same as b divided by negative 1 over 4. So to work this out, we are going to say we take b, we multiply by the inverse of negative 1 over 4. In other words, we have negative 4 divided by 1. So which is equal to negative 4b. So the whole thing is negative 4b, not negative 4 over b. So we have negative 4b. If we work this out, we get negative 4b. So now we still need to determine the value of b. So here we have negative 4 over b divided by 1. So now we can apply the cross multiplication. So if we cross multiply here, we are going to have negative 4b squared, and then we say equal to negative 1. So b squared, to get b squared, we need to divide both sides by negative 4. We have negative 1 divided by negative 4, which is also equal to 1 over 4. So we have b. So I'm going to continue the resolution on that side. So we have b square is equal to 1 over 4. Therefore, b is equal to plus or minus square root of 1 over 4. So we are going to have two values of b, since we want to determine the square root of 1 over 4. So we have two values of b here. So the first one is 1 over 2, and the second one is b is equal to negative 1 over 2. So these are the value of b. So we have two values of b. The first one is half, and the second one is negative 1 over 2. Question 2.2. Let's say if b is equal to half, calculate the 19th term, which is symbolized by t19 of the sequence. So the value of b is half. So here we are going to get the common ratio. So we can first write down the formula for Tn. We know that Tn is equal to A multiplied by the common ratio to the power of n minus 1. So I'm going to say T19 is equal to, so A represents the first term. So in that case, A is equal to negative 1 over 4. So we have negative 1 over 4 multiply by the ratio. So I'm going to determine the ratio soon. So n in that case is 19, since they want us to determine the 19th term. So we just write down 19, and then we have minus 1. So now how can we determine the common ratio? So we have the first term and the second term. So the second term is 1 over 2. So we know that to determine the common ratio, we take the second term divided by the first term. So I'm going to say R is equal to the second term, which is B. B is half, divided by the first term, which is negative 1 over 4. So now we can simplify this using the cross multiplication. So we multiply by 4 and then we divide by -1. So that gives, if we continue with this simplification, if we work this out, we are going to get -2. So that is the value of r. So now we'll just replace r into the expression of T19. So we're going to have T19 is equal to -1/4 multiplied by, so the value of r is -2. And then here we have 19 minus 1 gives 18. So if we use the calculator to compute this expression here, we'll end up with T19 is equal to -65,536. So that's the answer. Question 2.3. We say if b is equal to half, write the sum of the first 20 positive terms of the sequence in sigma notation. So we have the initial sequence, which is -1/4, and then the value of b, which is 1/2, and then we have 1. So if we continue in the sequence, we can just add some terms that comes after. So since we know that the common difference, the common ratio is -2, so here if we multiply -2 with -1, we get 2, and then we multiply 2 by -2, so we're going to get -4, and then if we multiply -4 again by -2, we are going to get 8. So this is the same as this sequence is the same as that one, but we just add some value so that we'll see what's going on. So in this sequence we realize that there are terms that are positive and there are also terms that are negative. So here we are going to focus on the positive term, because here they want us to determine this the sum of the 20 positive terms. So we need to focus on the positive term. So we have that one which is positive, that one which is positive, and that one which is also positive. So we can call that as T1, and that is T2, and that one is T3. So if we consider T1, T2, and T3, we have a second geometric sequence, since if we determine the common ratio between the second term and the first term is the same as the common ratio between the third term and the second term. So here we can see, because if we have 2 divided by the first term, which is 1/2, we are going to get 4, which is the common ratio. So 4 is the common ratio in the actual geometric sequence. Same thing if we have 8 divided by 2, we can still get 4. So 8 divided by negative 8 divided by 2, we still get 4. So in other words, the actual arithmetic sequence is made of T1, So we have T1, which is half, and T2, which is 2, and T3, which is 8. So now we need to determine the sum of the 20th number in the actual geometric sequence. So we need to use the sigma notation. So here we can just say sum of, so from n is equal to 1, because we need to start from the first term, up to n is equal to 20. So the sum, and then next to it we write the expression of Tn. So Tn is given by a r to the power of n minus 1. So where a represents the first term, so in that case the first term is 1 over 2. And then the common ratio is 4. So the common ratio in the actual geometric sequence is 4. So we have 4, and then on top we have the exponent, which is n minus 1. So in that case n is, so if we write the sigma notation, we want to make sure that we express everything in terms of n. So I'm going to repeat n, and then we say minus 1. So that is this, what is called sigma notation. So we just use that formula. We need to make sure that we have the value of a, the value of r, but we only repeat n as it is. Question 2.4. They say, is the geometric series formed in question 3.3 convergent? Give reason for your answer. So if we look in the previous question, we have the actual geometric sequence. So we have the first term, which is 1 over 2, the second term, which is 2, and the third term, which is 8. So now they say, is the geometric series formed in question 2.3 convergent? So to know if the geometric sequence convergent, we need to determine the value of r. R represents the common ratio. So in that case, r is equal to 4. So we say r is equal to 2 divided by 1 over 2. So the second term divided by the first term. So we're going to get 4. So we can also say that r is equal to the third term divided by the second term, 8 divided by 2, which gives 4. So the geometric sequence is convergent when r is less than 1 and at the same time is greater than -1. But if we look at r here, in that case r is not in that range. So we are going to say that the geometric series is not convergent. Since r is greater than 1. So if it was between -1 and 1, then we would say that the series is convergent. So that r is greater than 1 and r is also greater than -1.